Here we go. Let's get started. No need to see my face because you see it daily in class. So here we go. We're talking about electric charge and electricity for the rest of this semester. So here we go. Electric charge is a property that causes subatomic particles like electrons and protons to attract or repel each other. In this case, we're talking about two types of charges, simply positive and negative charges. If we want to get into more detail, we're talking about protons and electrons. Protons are positively charged, electrons are negatively charged. That's the more detail. Then you have this thing called electric force. It is the force of attraction between electrically charged objects. Like charges repel, opposite charges attract. So if I put two positive charges next to each other, they will push each other away or repel. Or if I put two negative charges next to each other, because they're like, they will push each other away or repel. But if I put a positive and a negative charge next to each other, they are opposites, so they will attract each other. And that is the electrical force of attraction between them. And then you have this thing called static electricity. The study or behavior of electric charges, including how charges transfer between objects. So, like when you grab that doorknob and it shocks you, or you touch somebody and they shock you, that is static electricity. That is the transfer of electric charge. Let's talk about how electric charges behave. Most objects are neutral. That means they have equal number of positive electric charge and then negative charges. So when my positive and my negative charges are equal to each other, they cancel each other out. So the object is neutral. Objects become charged when negative charges move from one thing to another. So let me make this very clear. Positive charges do not move. Positive charges do not move. Positive charges do not move. Only the negative charges or electrons will move from one object to another. So, example, if I took a balloon and somebody in class let me use their hair, I blow the balloon up. I take the balloon, I rub it against somebody's hair. Okay? That balloon now becomes negatively charged. Why? Because electrons or negative charges from the person's hair move to the balloon. So now the balloon is more negative. That person's hair now is more positive. Why? Because it lost negative charges. So if I now put that balloon next to the hair will stick or attract to the balloon because those two objects are now oppositely charged. Okay? So two objects with the same overall charge, which are likes, they will repel each other, and two oppositely charged objects will attract one another. Let's talk about voltage. Voltage is a force that pushes the current through a circuit. It is like gravity. Gravity pulls things downward toward the center of its mass. Voltage also pushes or pulls uh, electric charge or current through a circuit. So when you look on your batteries, your AA, AAA batteries, they say 1.5 V or 1.5 volts. That is the amount of force that battery has. It has a 1.5 volts of force to push current through the circuit. Okay, so whenever a wire connects to terminals of a battery or generators, the voltage will push and pull electrons through the conductor or through the wire. That is voltage. Resistance. Hopefully, you can apply some common sense to resistance. In this case, when we're talking about electricity, it is the friction that impedes, slows, or prevents the flow of current through a circuit. So it's anything that gets in the way of something moving. That's what resistance is. Example, if somebody was trying to walk out this classroom and I grab them, I am resisting them. That means I'm preventing them from leaving the classroom. That's resistance. In the case of electricity, you have resistance or something that prevents the flow of the electricity. It happens in a river. When there's a lot of rocks in a river, those rocks offer up resistance or they prevent the steady flow of the water down the river. Okay. That's what resistance is. It is an impediment. It is something that's trying to keep something from doing something. Okay. It is measured in ohms. And then you have current. which is the flow of electrons through a conductor in a circuit. It is measured in amps, and I'm sure everybody has heard the word amps. It's actually short for amperes. That's what current is measured in. So current is the flow. It's the flow. That's why money is called currency, because money flows from hand to hand, from store to store. Okay. That's why it's called a river current, because the water is flowing down a river. Okay. So in this case, electrical current, when electric charge flows. And let's talk about circuits real quick. We'll get more detail next week. A circuit is a closed loop in which electric charge flows continuously. Three parts that it has: a power source, which is a battery or outlet; a conductor, which is the wire that the electric charge is traveling down, and which is connected to a power source; and a receiver, which is also called a load, which is whatever's receiving the electricity, such as a light bulb. Okay. When the circuit is open, that means electrical current is not flowing. You have to close it in order to get the electrical current to flow. And you can open and close the circuit with a switch, like on the picture on the right. Last but not least, conductors and insulators. Conductor is a material that easily allows electrical current to flow. This ain't the first time you've heard the word conductor in this class. It is any material that easily allows the transfer of energy, whether it's heat or whether it's electricity. That's a conductor. And then you have this. So metals and materials made of metal, like paper clips and iron rods, are examples of conductors. Then you have insulators, which is any material that does not easily allow electrical current to flow or does not easily allow the transfer of energy. That's called an insulator. Examples: rubber, glass, wood, plastic. All those objects prevent the flow or the transfer of energy or the flow of electron. That's why electrical wires are wrapped in rubber, so that we don't kill ourselves. So the wire is not transferring energy or transferring electricity to us. So you wrap it in rubber as that insulator, prevent that electric charge from stopping our hearts. And that is all. Thank you.